All right, welcome back to the polynomial and factoring video series. Today we are on F5, difference of two squares. From here on out, we will refer to this as dots. Welcome back. If you did the spiral review, these are the answers you should have gotten. Probably the biggest issue we will see on this page is this first problem. If this were me, I would simplify the interior first. You have a 3 and a 12, which is going to give you a 1 and a 4 when you reduce that. An x to the fifth in your numerator over an x to the fourth in your denominator leaves you with 1x, and that's going to be left in your numerator. A y squared in the numerator and a y to the eighth in the denominator leaves you with 6 y's, and those 6 y's belong in your denominator, and this is all cubed. And then just remember, this power actually goes to everything. So this goes to the 1, the x, the 4, and the y to the 6. So 1 cubed is 1, and now we have x cubed. 4 cubed, 4 times 4 is 16, 16 times 4 is 64, and then remember your product properties. Y to the 6 cubed is really y to the 6 times 3, which is going to give you y to the 18. All right, on this particular problem, the numerator, anything to the 0 is 1, so now this answer is totally wrong, and our actual answer is going to be 1 over 12a times b to the 7. Even teachers make mistakes. All right, here we go on the last problem. 12 and 28 have a 4 in common, so we're definitely going to divide out a 4. You got an x to the fourth and an x, so we divide out a 4x, and after we do that, we're left with 3x cubed minus 7y. So hopefully we're getting better at these type of problems. All right, so we will flip to the dots card, and today we'll talk about the difference of two squares. So what is the difference of two squares? It is a perfect square minus another perfect square. And when we think about that, we have a very special way of factoring that, and if you will do this every single time, you will never get this wrong. First of all, you're going to take the square root of each term, and then we're going to rewrite the problem as x squared minus y squared, where x and y are the square roots, and then our final answer will be in the form x minus y times x plus y. What does that look like in a problem? It's almost easier to understand in a problem. So if we have x squared minus 25, the first thing we're going to do is take the square root of each term. So the square root of x squared is simply x, so we're going to have x squared, and the square root of 25 is 5, so we're going to have 5 squared. Then, remember, we're rewriting the problem as x squared minus y squared, which is what I just did. And the final answer is going to be in the form x minus y times x plus y. So I'm going to take x minus 5 times x plus 5, and I am finished. That's simple. However, do not skip this step. This step right here, totally mandatory for this entire unit. By doing this step now, as problems get more difficult, you will understand the whole process and procedure that we are using. All right. Next step, factor 9k squared minus 49. Probably the first thing we should really be doing all the time is asking if we have a greatest common factor. I do not have a greatest common factor, so I'm going to take the square root of each term. The square root of 9 is 3, the square root of k is k, and the square root of 49 is 7. So I'm going to rewrite this as x squared minus y squared, so this expression is equivalent to 3k squared minus 7 squared. And then last but not least, I will write my answer as x minus y, x plus y. And remember right here, this represents x and this represents y. So when I rewrite this, it's going to be 3k minus 7 times 3k plus 7. All right. Example 4. Every time these look a little harder, but I promise you, if you will follow the process, they are not that hard. So again, ask yourself, do you have a greatest common factor? I do not have a greatest common factor, so I'm going to take the square root of each term. The square root here, the square root of 4h squared is 2h. The square root of 81g squared is 9g. Do not worry about the sign because that's part of it being a difference of two squares. So now when I look at this particular problem, I'm going to rewrite this. This is 2h squared minus 9g squared. So we write it in the same exact format every time, which now means I can write my answer as x minus y times x plus y. So in this case, x is 2h, y is 9g, so 2h minus 9g, 2h plus 9g. All right. And now we have the fact problem 16 plus 25x squared. So if we think about what dot stands for difference of two squares. So immediately I see a big fat problem because right here I don't have a difference. I actually have the sum of two squares. For lack of better terminology, we'll call this a SOTS. And just so you know, these are not factorable. Okay, so if I try to factor this like I do all my other ones, if you try to do 4 minus 5x and 4 plus 5x, when you get ready to do this, well, it's all fine and dandy, but not really, because here we get 16, here we get plus 20x, here we get minus 20x, and then minus 25x squared. So these cancel out, but the problem is this sign right here does not turn into a plus. So you can try to go through all these steps if you want to, but because it's not a difference of two squares, you'll just write not factorable, or you could use our another amazing word that we learned earlier this unit, it's prime. Okay, moving on to the last example. So let's factor 9y squared, 9y to the fifth. Ooh, 9y to the fifth minus 81y. So I'm going to look at this. I'm seeing some GCFs here. I have a 9 and an 81, so I can technically factor out a 9. And I have a y to the fifth and a y, so I'm going to factor out a y. So I'm going to factor out a 9y before I start this because it's really not even a difference of two squares as it's written. If I factor out a 9y, I am left with y to the fourth minus 9. All right, so now if I take the square root of each term, the square root of y to the fourth is y squared, and the square root of 9 is 3. So if I rewrite this problem, I have my 9y on the outside. This has to come down every step. Don't get lazy and not write it because eventually you'll lose it. You have y squared squared minus 3 squared. So now I have 9y, and this is going to be a minus b times a plus b, or x minus y times x plus y. So this is going to be y squared minus 3 times y squared plus 3. All right, so that is all I have for today. So enjoy the rest of your evening. Short videos this week, and we will see you back in class tomorrow. Have a wonderful night.